What's going on, you guys? Mr. Allen here. We're going to be solving some logarithmic equations in this video. And for these 4 examples, we do not need to use any log properties. So let's get after it on the first one here. We got log base 2 of 3x minus 2 equals 4. So how do I solve a log equation? I've got an x inside this log here. It's the argument of the log. How do I get to it? I can't divide by log base 2. That's not how it works, right? But I can rewrite this in exponential form by using the patent-pending method here from the Thorn Dog, Mr. Thornley, the loop and the swoop. It helps you remember the order of things. You don't have to use it. I like to use it. 2 raised to the 4th power equals my argument of the log, 3x minus 2. So what is 2 to the 4th power? That is 16 equals 3x minus 2. I'm going to add 2. I'll get 18 equals 3x. Divide by 3, I get x equals 6. Now you'll notice here, check for extraneous solutions. You must do so when solving any log equations because our log functions have a domain restriction. It's got to be, the argument's got to be greater than 0. It can't be 0, it can't be negative. It's got to be positive. So my argument needs to be positive. Not my x value, but my argument. If I plug 6 in here, I'm going to get 3 times 6. 18 minus 2 is 16. We are good to go. Let me circle it. Let me circle it here. Boom. 6 is the answer, not extraneous. Awesome. Moving on over here to the right. I got log. No base. Weird. I'm all about that base. It's log base 10 when it's not written. Okay, if there's no base there, it's log base 10. Fun fact. Write that down. Of x squared plus 9x equals 1. So how do I solve this? Same as this one. Let's loop it. Let's swoop it. A lot of looping and swooping in this video. I got 10 to the first equals x squared plus 9x. 10 to the first is just 10, right? Anything to the first power is that anything. All right. So what do we do here? Well, I got a quadratic. I got to set it equal to 0, factor, my favorite F word, and solve. Don't panic when you see a quadratic pop up in any unit besides quadratics because factoring is here to stay, dude. It's never going away. It's there forever. Calculus and beyond, right? I think maybe. Anyways, subtract 10. Boom. It's equal to 0. Now I can figure out what multiplies to negative 10 while adding to positive 9. What would that be here? Got my 2 factors. How about positive 10, negative 1? That ring a bell? It does. 10 times negative 1 is negative 10. 10 minus 1 is 9. Checks out. So now I have x plus 10 equals 0 and x minus 1 equals 0, which you may just be able to do this in your head. You get x equals negative 10. X equals positive 1. Ooh, negative. Didn't I say something about negative? The argument can't be negative. If I plug negative 10 in, negative 10 squared is 100, positive 100. Minus 90, that's positive 10, so that's good. Plug 1 and I get 1 plus 9, that's 10. They both check out. Both solutions work. Cool? Awesome. Fantastic. Wonderful. So anytime you are solving with logs, you got to check to make sure that the argument's positive. I'm not necessarily always like evaluating and doing everything to make sure the equation is true on each side. It's more so a quick check to make sure that I don't have a negative in the log, in the argument of the log, okay? The argument of the log is what's in the parentheses here, here, here. That's referred to as the argument of the log, okay? So if you hear someone saying that, they're doing bougie math talk, right? You got to follow along, okay? This one here, first thing, interesting, I got a coefficient. How about I go ahead and just divide this by 5, right? It's multiplication. I could divide by 5. So I'm going to have log base 3 of 6x minus 3 equals 3. Yay! I can do it just like these now, right? Cool. Loop it, swoop it, and moving on. So we get 3 to the third equals 6x minus 3. So I got 27 here. Equals 6x minus 3. I'm going to be running out of room here. So I'm going to move on up over here. Whoop. So if I add 3, I'm going to get 30 equals 6x. Divide by 6. I get x equals 5. Can I circle that? Can I circle? Let's check. Check it. 30 minus 3. That's positive. It's 27. We're good to go. Not extraneous. Yay! Did that fit on the screen? I hope so. Whoa. Missed part of my circle there. But I think we got everything else. Good. Cool. All right. Last one here, dogs. Last one. Already ready to go. Ready to rock, man. I can loop it. I can swoop it. And it looks like we got ourselves a nice little quadratic once again. Perhaps factoring makes a return. So I got 6 squared equals x squared plus 5x. What is 6 squared? I believe that's 36. Is that right, Jenny? Cool. Jenny's chilling in here. She's taking a nap. She fell asleep in math class. All right. Subtract 36. Got to set this thing equal to 0. It is a quadratic, so I got to use the zero product property to solve, right? That's what we're using here when we factor and we solve, the zero product property. So let's see. We got 0 equals what multiplies to negative 36 and adds to 5. Hopefully those factors are on the board. They are. And I've got, let's see here. How about, well, 6 and 6 multiplied to 36. No. 1 and 36. No. 2 and 18. No. 3 and 12. No. I seem to be avoiding 9 and 4, aren't I? Don't forget about your 9s, dog. So I got 9, I got 4. Which one's positive, which one's negative? I want positive 9, negative 4 so that it adds to positive 5, all right? So if you have to, work through all your factors like I just did right there. You know, I didn't just know that it was 9 and 4 right off the top of my head. Or did I? I don't know. Okay, so here I've got negative 9 for this one. X equals negative 9. And here x will equal positive 4. So do they both work? One work, none work? Because there can be no solution when solving with logs. It does happen. It's happened in class before for me. It happens. You're like, oh man, no solution? Lame. If I plug in negative 9, that's 81 minus 45. That's positive. Plug in 4, 16 and 20. That's positive. Both these bad boys are good. Nice. All right, guys. No extraneous solutions here. You will find that it's rare that we have extraneous solutions in these, but once we start using properties and they're like expanded form, you condense, that's where you really got to look out for your extraneous solutions. Not that it can't happen here, but it's just more common with those other ones where we're involving properties and things are going from linear to quadratic, crazy stuff. All right, hopefully that helps there, guys, and keep on watching these because we're going to be logging some math hours here. No pun intended, actually pun intended. See you later.